Hello, my name is Ricardo from 12.3, and today I will be showing how to find the area of a picture with the integral. So the step number one is to put the picture of the area you want to find. In my case, this is algal blooms from Cuba, and what I will use to measure the algal blooms will be chlorophyll concentration in the Gulf of Mexico. Here is all the way from 30 to 0.001, and I will basically measure the areas that are greenness from basically like from here to here, and use those to gauge the amount of algal bloom found in the area. So, for example, if we wanted to find the amount of algal bloom in this area here, we will have to find, firstly, the units we will use. In this case, I will use miles squared. In order to convert the units that we have in GeoGebra in the x and y axis, as you can see here, to real units, we will first need to choose the length of the picture. You can choose any length. The point is that you have to make a conversion. To make it easier to convert the GeoGebra units to real units, I chose 18 because at that point, if you go to Tools, Point, and you put 1 point here and 1 point here, I can use GeoGebra, I can use Cuba as a reference, and because I know Cuba has a length of 777 miles, I know that the total length from here to here should be about 7.77 in order for me to use 0.01 units as a mile. So each 0.01 unit in GeoGebra will be 1 mile in real life, given the way I put this. And as you can see, if I were to find the distance in Tools, you go down and find distance from C to D, you will find that the distance is about 7.77, in this case 7.29. Depending on where you put the points, the distance may increase or decrease, but the point is it should be around the value that you want to make it easiest. You can just use either, in another scenario, use a conversion and convert using a simple math to convert from units in GeoGebra to units of real life. I made it this way so that it's easier. So after you have the picture and have decided on your units and their conversion, the next step is to go to points and use the points that you choose. Click point, and then you can click on the area you want for there to be a point at. In my case, I will choose points that surround the area so that the functions can trace the graph. And basically what I will do for the remainder of the video is first find the functions that border the graph, and then find the area between those functions that will give me the area that I desire. So firstly, to find the two functions that I want, I put the points F, E, and C, which are relatively accurately placed on the graph, so that the function that passes through all of these points will pass through the border of the area that I want to find. To find the actual function given the points that I chose, these are F, E, C, and for the second function, G, H, and I will go to algebra, this part here, click algebra, and I will put integral. I will put the function for a function that fits all the points that you put on it, which is in GeoGebra fit poly. So you write fit poly, and you click the first one that appears, not the freehand function, the one that uses a list of points because it's more accurate. So for the list of points that we'll use F, comma, E, comma, C. You have to separate the points by a comma, and you can additionally and you can just hit enter and it will make the function for you. If you want extra specifics, you can put the little bracket, curly bracket here, and then put a comma outside of those curly brackets, and you can choose the degree. You can choose a degree that's bigger than that's equal or bigger to the number of points you have, because the function will not have the correct number of roots to graph that. But you can choose of any function that is smaller. For example, if I wanted a linear graph, I could choose 1 and it will give me a line. If I were to put another point, I could choose 3 and it will give me a line. In this case, I will choose 2 because it's most accurate, and you can just pick the one that is most accurate. With higher degrees, you have to be careful because they may be too big, and the function might look very strange and not be as accurate as you wish. For the second function, I will do the same thing, fit poly, and you can just put fit and you can find it here. It's right here, and the list of points will be G, comma H, comma I, and hit enter. It does the parabola on its own because that's the maximum number, So now that we have the two functions, we will just find the area between them. The function for integration here between two functions is integral between. We will choose the one that uses x values and not the one that uses Boolean evaluate. So for the functions, the first function, you can see the function, which function is which here at the edges. It marks them in the same color as a letter. For example, the gray one is G, as you can see here, and the purple one is F. You can also see them here on the side. So for F, since we want F on the top, we'll put it first. F of X will be the first one, and the second one will be G of X. From where to where we will find our integral? Well, we can decide from where to where. In this case, to make it most accurate, we will find our integral from F actually. The x value of F is 10.15, which is, we'll just take 2 decimals for convenience. You can take more if you want more accuracy. And we will take the other point as C over here. You can move the points around, by the way, to make the graph fit better, make the function fit better your picture as you want. We'll choose C as which more or less lines up with this area. So that point would be, that x value would be 10.51. So 10.51, and we'll hit OK, and there we have the area between the functions, which will approximate the area that we wanted to find to begin with. If you wanted to do this for more parts, you could repeat this process, find the two functions, just pull out points, you hit tools, point, you put any amount of points that you wish to place here, and then you find the functions that fit the graph as much as you'd like and as accurately as you'd like. Then you go to algebra, plot the functions, and find the integral between the functions. It's important to note that the points graph themselves on this left column here, and that's about it. So have good luck with your project, and bye.